Let's have a look at the 2024 Higher Level Maths Leaving Cert Paper 2, question 6. So we have a line segment AB. The point 611C divides the line segment AB internally in the ratio 1 to 3. A is the point 113. Find the coordinates of the point B. Okay, so let's just draw a line segment first. So let's take this as A and this as B. And we have a point C here somewhere. So let's see, C is the point 611. And the ratio is 1 to 3. So A is the point 113. And we've got to find the coordinates of B, which we'll call it x2, y2. Okay, so what we're going to do here is use a formula in your tables, and it is B x1 plus a x2 over b plus a. That's the x coordinate of this point here, and then the y coordinate would be by1 plus a y2 all over b plus a. That's our y coordinate, that's 11. So let's write down a few other things. We have the ratio is going to be a to b. So in other words, a is equal to 1 and b is equal to 3. This here is going to be x1, y1. This is x2, y2. And these two are these 2 points here. So let's write down a couple of equations. So we know then that b, which is 3, times x1, which is 1, plus a, which is 1, multiplied by x2, which is just x2, all over b plus a, which is 3 plus 1. That's this here, and that's this here. That's going to be 6. We just got to solve that. On the other hand, then I'm going to do this one. So you've got b, which is 3. We've got to multiply that by y1, which is 13, plus a, which is 1. We've got to multiply that by y2. That's over, again, 3 plus 1, and that's going to be equal to this number here, 11. So we've really just got to solve these. So let's see, this is 3 plus 1, which is 4. 4 times 6, 24, and then on the left hand side we've got 3 ones, 3 plus x2. So that will, well, I'll actually just do this one first. 3 and 1, 4, 4 11s, 44, 3 13s, 39 plus y2. So here we get our x2, which is 21, and here we get our y2, which is 5. So in other words, B, so our answer then, if you like, our answer B is going to be 21, 5. Okay, so let's have a look at B. Find the perpendicular distance from that point to that line. So again, this is a formula in your book. The perpendicular distance from a point to a line is given by the modulus of ax1 plus by1 plus c, all divided by the square root of a squared plus b squared. So let's just write down what all these letters are. Let's have a look at our formula first. Our formula, or equation of the line rather, is y is equal to 4 over 3x minus 11. So that's just going to be 4 over 3x minus y minus 11 equal to 0. I've just put that in the form ax plus by plus c equal to 0. So we can see here that a is going to be given by 4 over 3, b here is going to be given by minus 1, and c here is minus 11. So that's our a, b, and c. Our x1, y1 is going to be this point here. So we've got the point 5 minus 2. I'll put it over here. 5 minus 2. So that's going to be our x1, y1. So I think that's everything we need to put in there. So let's do it. So it's going to be the modulus of a, which is 4 over 3, times x1, which is 5, plus b, which is minus 1, times y1, which is minus 2, and then we got plus c, which is minus 11. Okay, so that's our top line. Bottom line is then just going to be the square root of a squared plus b squared. So it's 4 over 3 squared plus a b, which is minus 1, which we've got the square. So this is our answer here. Well, let's just sort all this out. So we have 4 5s 20 over 3, minus times plus is minus, minus times minus plus 2 minus 11 all over. Now we've got the square root of 4 over 3, so 4 4 is 16 over 9 plus 1. Just come over here. So on the top here you get minus 7 over 3 actually, but you've got to get the modulus of it, so it's 7 over 3. On the bottom then 16 over 9 plus 9 over 9, if you like. The 1 is just 9 over 9. That's 25 over 9, so that's, you've got to divide by the square root of 25 over 9. So that's 7 over 3 multiplied by, well, the square root of 25 is 5, the square root of 9 is 3. We've got to flip that upside down and multiply, so it's going to be 3 over 5. So our answer finally then is just going to be, the 3's will cancel and we just end up with 7 over 5. Okay, so that's that part. Let's have a look at the next part. We have part C here. In the coordinate diagram below, 16 points are marked with a dot. These are all of the points of the form Mn, where M and N are natural numbers and M and N are less than or equal to 4. A pair of these points is picked at random. How many different pairs of points can be picked from these 16 points? Okay, so this is just going to be 16, choose 2, which is 120. This is like having 16 people standing in front of you and you've got to pick a team of 2. How many different ways are there of picking a team of 2? So you can't repeat any pairs. So this would be 16 choose 2 rather than 16 P2, which would be arranging pairs rather than choosing. Okay, so that's the first part. The second part then says the 2 points that are picked are joined with a straight line. Find the probability that this line is horizontal. Okay, so the way you can look at this is, let's say we pick this point here. We can only go across this way. There are only 4 options here really in terms of horizontal lines. So let's say we pick this. We can join it to this one, we can join it to this one, and we can join it to this one. That's 3 horizontal lines. We can take this one, and we can't go back again because we've already chosen that one. So we can go here, and we can go here. So that's 2. Then we can pick this one. The only one we can join that to is this one here. So that's 1. So that's a total of 6. So that means we have 6 possibilities on this line, and it's going to be the same for this one, and this one here. So it's going to be really 6 times 4. Which is 24. So we have 24 possibilities out of a total of 120. So it's going to be 24 out of 120, which is equal to 1/5. And that's it. So the probability of picking 2 points, 2 different points, and that they are joined with a straight line that's horizontal is 1/5.